I'll just play this mirror neurons from where I stopped.
Hello again. Oh, fire. Now, the monkey... They're both doing something. Seeing and doing were the same. Or more intriguingly, that for this neuron, watching somebody do something is just like doing it yourself. The head of the lab, Giacomo Rizzolatti, thought, wow.
The same neurons, one neuron, fire both when the monkey observes something and when monkey is doing something. It's almost unbelievable.
It was surprising because this cell which was involved with motor planning for the monkey turned out to be interested in the movements of other people as well.
Some people call them monkey see, monkey do neurons, but the name that stuck is mirror neurons, because with them, the brain seems to mirror the movements it sees. This accidental discovery got scientists thinking, doing more tests, and it soon became pretty clear that this is not just a monkey thing, it's a people thing too. We all know that humans learn by looking and copying. That's what infants do. First you look, then you do.
Ready? Let's see your feet this way.
And once you've watched and copied and learned a set of moves, you not only have them in your head.
Look, you put your shoe on. Yeah, she brushed the
If you see somebody else doing it, you can share the experience.
And I want to do it with me.
They know the moves, you know the moves, so you can move with them.
Wow.
If you can use the years of training that you yourself have done, learning to crawl, then learning to walk, then learning to eat, this is an incredibly rich set of knowledge that you could apply to the problem of actually seeing what's going on.
So that's why when I head down this street carrying all of these packages, not only do people watch, look how they're watching. They feel my predicament, because they know what it's like to carry heavy packages. They all know about carrying. So as they watch me moving, they can feel themselves moving. Their neurons are mirroring the action. These neurons may be the brain's way of translating what we see so we can relate to the world.
The mirror system is the way that you tap into, the way that you harness your own abilities and project them out into the world.
Actually, there are some studies, very interesting studies also, which says that imagining that you are exercising also gives you around 30% of benefit that if you actually do the exercise. So you can imagine that you are doing push-ups or you are running or do something, 30% of that energy is consumed by imagining only. And that is because there is a threshold for your motor actions. You know, we have a lot of information which is connected to the motor system. Language, which connects to motor area. Vision, audio, a lot of things are going into motor area. And motor area cannot take every information and act on it. It has to filter it. So there is a threshold above which if you fire, your hand will move or your body will respond. Below that, motor areas do not respond. But the point is that your motor areas are always activated at certain level. It doesn't go beyond the threshold, but it's always activated. So people claim now that, and I practice it, close your eyes and imagine that you are running. And you will get the 30% of that benefit. So I should also make it little more clear that last class was mostly about giving you, things that, okay, see, this happens. World is different. World is created by mind. Today we are actually talking about methods through which we understand this thing. But these are physiological understanding. We do experiments and we find something. But that's not the whole picture. The whole picture is when you theorize it, when you make sense of all this data that you are getting. So all these experiments, for example, take the case of mirror neurons. The experiment suggested that when I perform an action, my motor area activates, the same brain area activates when I see others perform. But this data doesn't make sense actually, it doesn't tell you much. You need to make a theory out of it. How is it applied? So it is now applied on empathy, how we learn from people. So these 2 days, I'm just focusing on the incoming of physiological data and methods. Next 3 we will be talking, next 2 class we will be talking mostly about the conceptual part, where memory and other things also come into play. The last class will talk about the application of all of this. So bear with it. Anyone who has gone through EEG? Anyone experienced EEG? No? No, that's bad. Once in a lifetime you should go. And what they do is that they just put, now there are a lot of channels. You have different points. You can have 32 channels, 64 channels, 128 channels, 256 channels. Now these channels are basically small electrodes that are placed on the top of your skull. And it's called electroencephalogram. The point is that when the information passes from one neuron to another, it produces electricity. It's only the electricity which is passing from one neuron to another. And when that happens, you can actually measure it. So the assumption basically is that when I ask you to do a task, a part of your brain will be activated, and when it is activated, it will produce electricity, higher amount of electricity, because more information is passing. And when that is happening, I can record it and say that which part of your brain is getting more activated. It has a problem. The problem is that the brain is not only on the skull. Brain has a depth. So if something is happening in the deeper part of your brain, that doesn't come up so far, or like it's a small electricity and then lot of things are happening. So you estimate, there are lots of statistical analysis, but you get different kinds of things. But still, it's an interesting method to understand brain. I'll talk 2 experiments that actually gave us very interesting ideas. One is related to language. Anyone who studies language or linguistics here? Or interested in linguistics? So language has 2 parts. One is called syntax and the other one is called semantics. But there is something called pragmatics also. But you can have a lot of things, but actually in this case, syntax and semantics. What is syntax? Syntax is, anyone?
The words order in a phrase.
Okay, so it's more of a grammar. The way the structure is done. And what is semantics? Meaning. Okay. So semantics and syntax. Chomsky talks a lot about syntax and he has formalized it also. One EEG experiment which was done by these people, they found very interesting stuff. This is the time duration of EEG power, and actually the resolution varies. A good one will have 2040 hertz also. So in a second you get 2040 points of data. And this is the, what do you call, intensity. There are 2, 3, but N400, they call it N400. N400, N stands for negative and 400 stands for milliseconds. So what they actually found was that when people read semantically anomalous sentences, which means that if I say that whipped cream tastes anxious, whipped cream tastes sweet is fine, it's okay. There is nothing wrong in that. But if I say that I feel guitar, it doesn't make sense, because what do you mean by that? So syntactically it's fine, there is no problem in structure. It's only the semantics which, or meaning doesn't make sense. When people experience it or listen to it, they always produce something called N400. So whenever you read or hear whipped cream tastes anxious or any sentence which has semantically nonsensical statements, you get N400. And you can find out by just analyzing their brain areas, or this EEG. You also have something called P600. N is for negative, so you get N400. I don't know, for some weird reason, I have never understood it, they make it upside down. So negative in this case is up, positive is down. That's the tradition. And when you get syntactic manipulation or sentences which do not make sense syntactically, structurally, the spoiled child throws the toy on the floor. The spoiled child throws the toy on the floor. There is a grammatical mistake here. S is missing. So when you find that syntactical problem, you produce P600 and it can be found. There is also something called P300, which is related to images. That whenever you see something wrong with an image, you get P300. Now it has lots of implications, but EEG allows you to look into the brain when it is processing the language. This is a very interesting experiment, Libet's experiment. Okay, all of us have free will, right? That's why we are sinners. Since we have free will, we did something wrong in, somewhere. And then finally the result is that we are sinners. We have free will. If you want to go out of the class, you can always go. No one is going to stop you, right? This experiment, which was an easy experiment by Libet, posed a problem on that. What the experiment was this. I couldn't find a video for this experiment actually. So I don't have a video, I'll explain it. The experiment was that a person comes, sits, and then you put all these electrodes in his head. It's basically a cap, you just put it. And they are connected with the amplifier because it amplifies the current. And in the screen, you have something called this red dot which moves in circle. It goes continuously. And the subject is asked, or participant is asked to report when he or she wants to move his hand. So the task basically is move the hand. And whenever you move the hand, you become aware of it, you mark the position of red dot in this clock, which tells you the time. So what it actually does is that I feel like moving my hand, I move my hand. So there are two stages. One is that I am consciously aware, I with my free will deciding when to move my hand, and there is an action which says that I am actually moving my hand. So what do we expect? Think, even if we do not have EEG, what will be the sequence of our action, our brain? We decide first, number one, I need to move my hand. So there is a activation, some part of your brain which is responsible for your decision. Then that goes to motor area, and then motor area is given an instruction, move the hand. So brain actually tells the motor area or hand, move. Fine? This is how the general idea is, that this is how free will works. If I want to go out of the class, I will decide, okay, now I am bored, I want to go out. So the feeling of boredness or decision comes first, then your brain says, okay, move. Then your motor area starts moving, because you see that suddenly I say, fire! In class you will not run, but suppose on your road and suddenly I say, hey, fire, run! And you will start running without any time thinking. But actually a lot of things are going on, because your muscles have to be provided with lots of blood. Muscles just cannot move like that. You have to do a lot of planning. Muscles have to be given enough resources. Now in this experiment, what they actually found was the awareness of intention to act, if it is minus 200 milliseconds, and actually the motor area activates later also, the activity in motor cortex begins 500 milliseconds or around 500 milliseconds before you actually are aware that you want to move your hand. Now what does this mean? It actually means is that by the time you are becoming aware that I have to move my hands, your body is already preparing, as if the motor area knows that you are going to move your hand. And this casts a problem on the free will. What do we mean free will here? Because the body is already ready. It's preparing me for deciding to move, whereas I have not decided it yet. The decision happens here. Motor area activation happens 550 milliseconds before actual realization. Now, if you read about Libet's experiment, I suggest that read it. Lots of versions have taken place of this experiment. People have criticized him. He was so badly criticized for saying that you do not have free will at all. He had to retract. He had to say, forget it. You may have your free will. But then he made another kinds of explanation also, but it's interesting to read. But all that came from a very small experiment, which was EEG experiment and related to free will.